Mr. Coates here, going over today's learning targets for all of you. We are in Google Classroom right now getting this video. Next, you're going to go to Mathboard, and today we are using Zern. Okay, so as mentioned, in Mathboard, you're going to practice your facts for about 10 minutes. In Zern today, you're going to go to Lesson 1. It's in Module 3. The name of the lesson is called In and Out. Then in Seesaw, you're going to see inside the Activities folder there is a graphing activity. Do that first, so that will help prepare you to create a bar graph from our Connects car experiment data that we have. And then you're going to read an epic. Forces and Motion is the name of the book. It looks like this. As a reminder, you can find your Zern login right inside your planner. I've used Savannah's today as an example, but here your username, check that out, and everyone's password is 123. So it's the small white piece of paper that I cut and glued into your planner is your Zern login. If you don't have your planner or you can't find that anywhere, just message me in the Google Classroom comments and I can send that to you. And also, if you're doing Zern's activity today, don't worry so much about the student notes or the exit ticket. Just work on what is provided in the lesson. And when you're done with Zern, you're going to go into Seesaw, and in Seesaw where you find the Activities tab, the same place where you find your word sorts each week, I've put an activity called Reading a Bar Graph. Use the T to answer the 7 questions here. Here is a picture of the bar graph we are using in class today. You can see all of the information here. If you do have a printer at home and you want to print this out from Google Classroom, you're welcome to do that. If not, you can do this instead. Just grab a sheet of paper and a ruler and a pencil. All you really need to make a bar graph is a y-axis, which I'm about to draw here. So the line going vertically is your y-axis, and then turn the ruler so that you can have an x-axis. Be sure to give yourself some space on the sides, like in here, and down below here, so you can write some information. Okay? So the x-axis will be where we identify our number of turns that we put the rubber band around the rear axle. So you'll notice that in my number of turns, I had 2, 3, and 4 turns. Okay? Now along the y-axis, we need to give that a title. And the title along the y-axis will be how far did the vehicle travel in distance. And we're going to use centimeters to measure that. So the line paper is nice because each line I'm going to label in increments of 5 centimeters. So I'm starting on the first line and I'm counting up by 5s all the way up to 50, 55, oh, not 51, 55, 60, 65, 70. And this also gives you a little bit of a clue on how far our vehicles did travel. Because if our vehicles only traveled 25 centimeters, I wouldn't need a bar graph that goes as high as this one does. But some of our cars went as far as 110 centimeters. So there is an example of a setup of our bar graph. And then I'm going to throw some pretend data in here. You're going to get the real data, but this is just for pretend, just so I can show an example of how to make the bar graph. So each bar, if you noticed, I'm using my ruler so that I can make the lines as straight as I can. And let's say our second piece of data was about 20 centimeters. We're going to draw this bar up to the 20 centimeter mark. And neat shading is what's going to make our bar graphs look really nice at the end. Now you'll notice I'm just shading in pencil, but if you have colored pencils at home or crayons at home, bar graphs look a lot better when they're in color. So I think for the next few bars I'll put those in color. Now because we had 4 pieces of data on each of the turns, like for example, we wrapped the rubber band around the car twice and we got 4 pieces of data. So that's why there's 4 bars there. And you'll see I'll continue with 3 turns around and then 4 turns around. Okay, so 3 turns around the axle. This is, again, pretend data, but let's pretend it went up to 30 centimeters. And then we wrapped the car around 3 more times using the rubber band and let it go. And we did it again, a 3rd trial, and 1 more bar for that 4th trial. So we did 4 trials with 3 turns around the axle also. In the end, I have a completed bar graph. Notice there's 1, 2, 3, 4 trials with 2 turns around the rear axle. There's 4 trials with 3 turns around the rear axle. And I did 4 trials with the rubber band going around the axle 4 times. Okay, we need a main title, distance traveled. Again, the y-axis is how far it actually went, and that's what the bar actually represents. 85 centimeters is our highest distance. And this x-axis is the title of how many turns did we turn the rubber band around the axle. So again, this is pretend information. You're going to graph the real information next. And here it is, some real data. This comes from Maya's team. Maya's team had a vehicle. When the rubber band was wrapped around the rear axle 2 times, they took 4 different tests, and those were the actual numbers. With 3 turns around the axle, they raced their car down the track, and these are the actual numbers. And then you'll see with 4 times around, these are the numbers. So analyze the data you collected. What do you observe? So you might have to pause this video here so that you can look at the data carefully and begin your bar graph. All right, those of you working at home virtually, when your graphs are done, please post them in Seesaw so we can see your beautiful work. And lastly, you're going to go into Epic. You're going to read a book called Forces in Motion. It looks like this. Make sure you do that before the school day is over, so Epic will allow you in to read. All right? Enjoy your day, everyone.